All yours, please.
Hello, everyone. I'm going to talk about versioning data, about ML reproducibility, and the focus is your ML experimentation phase. In this phase, you usually deal with unstructured data, not databases, and it's crucial to keep track of all the data artifacts that you used in your ML projects. Share my screen. So a little bit about myself. I used to work at academia about 10 years ago. I was a data scientist at Microsoft Bing, and I a creator of DVC, open source tool for data versioning. And now we are running startup around DVC. So ML engineering phase, when people build ML models, it's a bit different from analytical and usual data scientist workflow. In this phase, you deal with unstructured data, which basically means just files. Usually a lot of files, dozens, sometimes thousands, in some cases millions of images. And to ensure that your project is transferable from you to your teammates, from you to DevOps to production system, you need to make sure it's reproducible. And then the question is like how to reach this with thousands and sometimes with many data files and sometimes large data files. So this is the problem that we are working on. But today I will be talking about general principles, like how to achieve this reproducibility and what kind of techniques you can use by yourself, even without the tools. So the problem is basically how to share your code with data and your model, how to keep them together and keep track of all the artifacts together. For code is clear, right? During the modeling phase, ML modeling phase, and software development phase, we use version control systems. But how to keep track of data and your models? So this is the major questions. This is the major question. So the first principle that a lot of people use, and it's very simple and straightforward, to assign a central storage for your particular project. So everyone will know. Everyone should know like where to find your data artifacts related to some particular ML project. It can be a bucket in S3. It can be some directory in shared NFS storage, or just some directory in a shared server that your team has. It's important to put all the data files of the models in this central place so you won't get lost you won't be wasting time on searching these artifacts. The second principle is not as straightforward, and usually it hurts you when you have like many files. You need to decouple your code from your data. So it usually means don't read data directly from your code, from your like Python script or any other code, because in this case you kind of your data evolution would be like tightly connected with the code, and it won't be it will be hard to maintain this data and code independently. For example, if a data set was updated, you will need to jump to code and to change it. It might be not a problem with a single file, but usually your flow of data engineers is more complicated, and a lot of modifications that's needed in code. And good practice here is just to have meta files, a meta file about your data artifacts. And instead of reading file directly, you should understand what is your file and what is location. So you can change locations of the files independently from your code. And by the way, you can version this meta file, and this is also give you like tight connection between your code and data. And the third principle, it's actually very simple, but very few teams doing this. it's important to keep track of all your metrics. And it's important to keep your metrics next to your code and your data, which basically means just commit your metric files. Those metrics files are usually not super huge, and it's fine to keep them in a Git history. And in this way, you will be able to use a Git for looking for the difference, right? You can take a look at the current metrics and see the difference to, for example, what is in production, what was happened like a month ago, for example. Those three basic principles helps you a lot to avoid all the problem related to sharing your models and make reproducible, make a reproducible ML projects. So let's talk about this principle and how those principles are implemented in DVC. So there are a lot of different tools for versioning. For unstructured data versioning, there are not too many actually tools, but you can still find some. And most of them are presented through Python libraries. What is special about DVC? It's a command line tool. It still has a Python API, and you can use it from Python, but basic use case, it's command line. And DVC implements all of those principles in a command line. So first of all, you can share, you can assign common storage place, a common directory as a data remote. We call this data remote. In Git, you probably know this concept of remote, right? Which is to your GitHub repository or some other place when code lives. And DVC introduced data remote, which is kind of directory when project data lives. And after assigning the directory, you will be able to push data or pull data back and forth. For decoupling data, DVC kind of codifies your data artifacts to meta files. So when you run DVC add some data file, usually data goes to your S3 bucket or NFS storage or whatever storage you use. But you can keep track of the meta files with kind of a pointers to the actual artifacts, to the actual location to the storage. And you can commit those changes, those meta files, and to make sure the connection between code and data. And the last principle is be metric driven. In DVC is implemented through metrics diff and plots diff functionality. When you can look at your JSON files to a history of your metrics files, to your JSON files or to your plots. So you can take a look at metrics change through different branches, through different commits, compare production with the current state, and plots can do the same thing for continuous data, which is usually also stored in JSON or TSV file. For example, in this plot, you see the difference between your previous commit and the commit that you have in the workspace. So yeah, please make sure your project is reproducible. You can transfer your project to your teammates, to your DevOps folks, and yeah, version your data. Thank you.